Okay, nerds, we're back at it. Day 3 of the introduction to sine, cosine, and tangent. And we're going to actually start evaluating some trigonometry now. And I'm going to be real with you. My memory is potato tier. It's bad. Really bad. Like, I can't remember anything, right? I have what they call CRS syndrome. Can't remember syndrome, you know? Okay, get CRS, real bad, right? So if you look up here, she's talking about this unit circle. You have to understand it and memorize it. Let me show you the unit circle in case you've never seen it before. It's this behemoth covered in coordinates, and you're supposed to, quote unquote, memorize that? Get real. Get real. You need to understand it. You need to know where it comes from. You know why I know you don't have to have it memorized? Because I don't have it memorized. That's why. So do I do trig as fast as the mathematicians that do have the unit circle memorized? Nope. But my answers are just as correct as theirs. So I'm going to teach you to do it the way that I do it. And that's without having it memorized. Because I don't have it memorized. All right. Unfortunately, there are a handful of things that you do need to memorize. Those handful of things are your x, y, r's for sine, cosine, and tangent, like I talked about yesterday. You know, sine is y over r, cosine's x over r, tangent's y over x. You do have to have that memorized. You also need to have the classic angles memorized in radians. So 30, 60, and 90, these are, well, 30 is 1/6 of 180, right? So this is pi over 6. 60 is 1/3 of 180, so pi over 3. And 90 is half of 180. Not so much important, but, you know, pi over 2. You need to have those memorized, for sure. And you do need to have this special right triangle memorized with the classic ratios that I'm about to write on it. Be aware, this triangle could be any size it wants to be, but these ratios will always hold true for every 30, 60, 90 right triangle. In case you don't remember, from geometry, the longest side of a triangle is always across from its largest angle, and by the same logic, the shortest side of a triangle is always across from its smallest angle. The smallest angle in this triangle is 30 degrees. So the side across from that 30-degree angle is my shortest side. What we do is we pick a value that is very easy and convenient to work with for that side. I like 1. In a 30, 60, 90 triangle, the longer of the two legs, because these are the legs, the longer of the two legs will always be the short leg times the square root of 3. So if you said the short leg was 1, this is the square root of 3. And if you can remember the Pythagorean theorem, then you'll be able to easily find out that this hypotenuse is 2. 1 squared plus root 3 squared, which is 3, get you 4. Square root of 4 is 2. And there you go. So this is a 30, 60, 90 triangle. These numbers are ratios in comparison to other sides in the triangle. This one's always double this one. This one's always root 3 times this one. So if this was a 5, this is 5 root 3, and this is 10. Okay? So it's not to say that every time you see a 30, 60, 90 triangle, these are its lengths. No, no, no. Those are its ratios. That's how they compare to each other. Cool? Okay. 45, 45, 90 is the other special right triangle. But like I said, you do need to have your degrees to radians memorized for these special angles. So we already know 30 degrees is 1/6 of 180, so it's pi over 6. 60 degrees is 1/30 of 180, so it's pi over 3. 90 degrees, half of 180, pi over 2. 45 degrees is 1/4 of 180, so this is a pi over 4. pi over 4, and a pi over 2. Do I ever call them pi over 4, pi over 4, pi over 2s? No. I always call them 45, 45, 90s because it's easier to say. Just like I won't call this a pi over 6, pi over 3, pi over 2. I'll call it a 30, 60, 90 because it's easier to say. But I know them as radians. When a triangle has two congruent angles, what kind of triangle is it? Isosceles. Yeah. That means these two sides are the same length. We pick a length that's easy and convenient to work with, like 1. In a 45, 45, 90 triangle, the hypotenuse is always side times root 2. Ta-da! So if this side was 8, and that was 8, this would be 8 root 2. So again, these aren't the side lengths of this triangle. These are the ratios of the triangle. It shows you these two are always equal, and this one's always root 2 times either one of these. That's what that shows us. I have now shown you everything that you need to have memorized in order to not have to memorize that giant circle with all those coordinates written around it. And to prove that point, I'm going to cover up the picture that is on these notes, and I'm not going to use it. It says find sine, cosine, and tangent for 30 degrees. Which quadrant is 30 degrees? Yeah, it's in quadrant 1, so we draw quadrant 1. And I'm going to throw a triangle in quadrant 1. It says 30 degrees, so I'm going to put 30 degrees there. Just throwing it out there, that's pi over 6. Just hoping if I say them a bunch of times, that eventually it'll set in by osmosis, you know. It'll accidentally get memorized. But yeah, 30 degrees, pi over 6 radians. Okay, anyway, this is clearly a 30, 60, 90 triangle. I don't need to put the other numbers inside it. I know that this is a 60, I know that this is a 90, whatever. What I do want to do is I want to put my side lengths on there. And I know that there should always be a 1 across from the 30 degrees. That means this time there's a root 3 sitting on the x-axis, and the hypotenuse is a 2. Do you have a question about it? No. Yeah, what's up?
Why did you choose those numbers?
Which numbers? 1 root 2 and or 1 root 3 and 2?
Yeah, how do you know it's not bigger?
It could be a bigger. These aren't its values, these are its ratios. So I have the ratios reduced down to the smallest unit that I could without having to deal with fractions. That's why. This could be, you could say this is y. This would be 2y. This would be root 3y. It doesn't even matter. Okay? Let's evaluate. Sine of 30 degrees. What I told you. You need to have your x, y, r's memorized. Sine is always going to be evaluated using y over r. So I'm writing y over r for now because, again, I'm hoping if you write it enough and see it enough and say it enough, it'll sink in. And then you'll have it memorized. Anyway, sine y over r gets me a value of 1 over 2. Sine of 30 degrees is 1/2. Sine of pi over 6 is 1/2. Cosine. Cosine is x over r. Root 3 over 2. It's like 1.7 and change, I think. And tangent. Tangent is always going to be evaluated by y over x. Y over x. 1 over root 3. Now, technically, you're not supposed to have radicals in the bottom of your fractions. we're supposed to rationalize that denominator. And we would do that by multiplying the top and bottom by root 3. It would get me root 3 over 3. But for now, we're not going to bother rationalizing our denominators because we don't know if you need to know them as rationalized or unrationalized according to College Board. So right now, we're not going to bother. I'm just going to say you could multiply the top and bottom of this by root 3. And you would get root 3 over 3. And it would be rationalized. Now let me prove to you that I didn't need this image. This is the unit circle. And you've been given the coordinate on the edge of the unit circle according to the 30-degree angle. You've been told that this is 30, see? So let's look at sine. What is y over r? Well, r is 1, right? So it's literally y over 1, which is y. What is my y value here? Cosine would have been x over r, but r is 1. So cosine of theta just would have been x. And tangent shows you why. One of the reasons why I don't have the unit circle memorized. Tangent's y over x. Fraction divided by fraction. And you'd have to do the whole keep, change, flip crap. Or you could just do this where there's no fractions and go, oh, y over x. Ta-da. I don't know the coordinates of the unit circle. I never have. My best friend that teaches pre-calc and trig at Northport High and also has a degree in mathematics, he's never memorized it either. Miss Stenson, who has taught just as long as me, longer actually, and teaches the other AP pre-calc course, and I'm pretty sure she has a degree in mathematics, also does not know the unit circle. Because why bother memorizing something when you could just put a triangle down and then figure out the numbers? Is it a little bit slower? A little. It is. Miss Klein can do trig faster than me. She can. She can't do it better than me, though. She's faster. Proving a point. I don't want to see this image. Not interested. I'm going to draw a 45-degree angle. What quadrant is that? Yeah, quadrant 1. We're staying at quadrant 1 for now. We'll break into other quadrants another day. Picture not drawn to scale. Never is, because who cares? But there's my 45-degree angle. Now, I know it's a 90-degree angle. I mean, if you want to put the little mark there, it'd be a stickler, whatever. There it is. Whatever, who cares? But 45, 45, 90s, we go with easy numbers to work with. So, 1, 1, root 2. Those are easy to work with. So you do have to have the two special right triangles memorized. And you do have to have memorized that 45 degrees is pi over 4. And you do need your x over y's memorized. Or x over y's, x, y, r's memorized. But that's it. Sine of 45 degrees is, well, I mean, I'll do it for now. Sine uses y over r, 1 over root 2. Cosine of 45 degrees, x over r. Oh, look at that. Also 1 over root 2. Okay, I lied. I'm not surprised. That's an isosceles triangle. Yes, what's up? So adjacent means next to, but the hypotenuse is always the hypotenuse. The radius is always the radius. But you notice I didn't say adjacent. See, I stay away from opposite and adjacent. Because when you don't have a triangle, and a triangle is impossible, which will happen in today's notes, there's no such thing as adjacent. There's no such thing as opposite. They stop making sense. So you just want to go to x, y, r as fast as you can. However, adjacent means immediately next to. And you can never say that about the radius because the radius is the radius. Okay? Lastly, tangent of 45 degrees. That one is y over x, which is 1 over 1, which is just 1. Look at my values for x and y. Look at this thing's values for x and y. So did I do it wrong? No. This is root 2 divided by 2. If you multiply the top and bottom by root 2, you get that. So this is just rationalized. And right now, Stinson and I don't think you have to rationalize. We don't think you have to know them rationalized. But if you do, we'll find out soon, and we'll just start rationalizing by multiplying the top and bottom by root 2 or root 3, whatever bad radical's down there, whatever. So what's the difference? This triangle is not on the unit circle. That's the difference. Because the unit circle has a radius of 1. So this is similar, meaning literally it's a similar figure. This is the triangle you get if you multiply this triangle by root 2. You'll get this triangle. Scale factor of root 2. Or you could say divide all three of these numbers by root 2 and you'll get this one. You'd end up with this little triangle. But sine, cosine, and tangent don't care the size of the triangle because they're ratios of side lengths. Okay? No, we're not done. No, we're finishing these notes today. 60 degrees, also quadrant 1. I know this is a 30, 60, 90 triangle. There's always a root 3 across from the 60. That means there's a 1 there, and I have the hypotenuse being a 2. Sine of an angle is y over r. Root 3 over 2. Cosine of an angle is x over r. 1 over 2. And tangent of an angle is y over x. Root 3 over 1. Root 3. Nothing to rationalize here. That's it for that one. So if you can draw and fill out a 45, 45, 90 or an appropriate 30, 60, 90 in any quadrant, then you could do trig by hand at any of the special angles. By hand. And that's without memorizing anything. The only thing you'll have to keep track of is x positive or negative here? Is y positive or negative here? That's it. And that's just based on the quadrant. Okay? Scoot. How do you do that? 90 degrees is not going to be a triangle. 90 degrees is what we call a quadrantal angle because it lands on one of the axes. Quadrantal. That's either on the x or the y axis. 90 degrees is on the y axis, isn't it? Now, this is one of those few times where I'll say, hey, let's just go ahead and say it's the unit circle. Whatever. That puts me here. It's a unit circle. So what is its radius? No. What's its radius? Not what's the angle. The radius of the circle. 1. It's a unit circle. So it's a radius of 1. So then what is the coordinate at that dot? 0, 1. So that's at 90 degrees, which is pi over 2 radians. And you could do this now with no triangle if you know your x, y, r. Sine of 90 degrees, which is pi over 2, uses y over r. Well, what is y? 1, and r is 1. So sine of 90 degrees is 1. It's y over r. Cosine of any angle is x over r. But what is x this time? It's 0. X is 0. So cosine of 90 degrees is 0. No triangles needed. No SOHCAHTOA. X, Y, R. And tangent, which is y over x, gets me 1 over 0, which is undefined. Spoiler alert, tangent is undefined anytime you're on the y-axis, because x is 0 there. So I'm undefined for tangent at pi over 2 and 3 pi over 2. And any coterminal angle there. So plus or minus 2 pi here, plus or minus 2 pi. Yes, sir?
And if the angle was at 0,
If it was at 0 here, yeah?
the radius would be
Still 1. It's the unit circle, so the radius is 1. Okay? Don't worry, that happens in the notes. But yeah. Anytime I'm working with a quadrantal, I just go ahead and say, all right, let's just let the radius equal 1, because it doesn't matter what the radius is. For example, if the radius was 2, this coordinate would be 0, 2, right, Mark?
Yeah.
Okay. So if this was 0, 2 and the radius was 2, sine would have been 2 over 2, which is 1. So it doesn't matter. The size of the circle is unimportant to trigonometry. But if you're on the unit circle, sine, which is supposed to be y over r, what is r on the unit circle again? 1. So then sine of theta in the unit circle is equal to the y value of a coordinate on the unit circle. Look here. The y value. Because it was the unit circle. Cosine is x over r. But if you're in the unit circle, r is 1. So cosine in the unit circle will always give you the x value of any point on the edge of the unit circle. See? The x value. And tangent is equal to the y value divided by the x value. If it exists, obviously, because sometimes the x value is 0 and you can't divide by 0. The radius can never be 0. So sine and cosine are always defined. But tangent can be undefined every now and then. Calm, cool, and collected? We doing all right? All right. Like I said a few dozen times, I don't have the unit circle memorized. So what I'm going to do for these is I'm going to draw a triangle. So I'm going to draw a triangle to each one of these rows. All my triangles look the same. I just put different numbers in them. And if you want to put the little 90-degree angle marks in it, you can. So here I'll put a 30-degree angle, which is a pi over 6. Here I'll put a 45-degree angle, which is a pi over 4. And here I'll put a 60-degree angle, which is a pi over 3. And then I just fill out my triangles. Across from a 30, I'll always find a 1. So that fills out my 30, 60, 90 triangle. 45, 45, 90 is easy because this is 1, 1, root 2. And at 30, 60, 90, across from a 60 is always a root 3. And we're ready to rock and roll. Sine always gives me, or is always found by y over r. Cosine is always found by x over r. And tangent is always found by y over x. Now we just fill them out. Here, sine is y over r, 1 over 2. Cosine is x over r, root 3 over 2. Tangent is y over x, 1 over root 3. Again, I don't know if we have to rationalize the denominators. I don't think we do. At least Ms. Stinson doesn't think we do, and I hope we don't have to because I don't see a reason in it. If we have to, we'll come back at a later point in time and we'll just get used to rationalizing denominators. All right, here we go. Blue. Blue feels good. Here, y over r is 1 over root 2. X over r is also 1 over root 2. Yeah, because, isosceles. And tangent is y over x. 1 over 1 is 1. In the last triangle, 60 degrees, sine is y over r, root 3 over 2. Cosine is x over r, 1 over 2. Tangent is y over x, root 3 over 1. Ta-da! So if you know these triangles, and you know this, and you know that, all trig evaluation is yours. You'll never have to struggle trying to memorize a unit circle. Told you I didn't make it up. Quadrantal angles. Look at these coordinates. What's the radius of this circle? This is the unit circle, radius equals 1. Sine y over r. Cosine x over r. Tangent y over x. At 0 radians, 0 degrees, sine y over r, 0 over 1, 0. At pi over 2 radians, y over r is 1 over 1. At pi radians, y over r is negative 1 over 1. And at 3 pi over 2 radians, y over r. Something stupid happened. I just realized it. This one here, the y value is 0. Sorry. We chalk it up to low blood sugar. I'm hungry. Cosine x over r. Hey, you know what? If r is 1, you know all I have to do is look at the x value, right? Because it'd be x over 1 no matter what I do. So it's just x. So let's look at cosine of 0. What's the x value there? 1. How about that? Let's look at cosine at 90 degrees, pi over 2 radians. What is x there? 0. Since r is 1, just looking at the x value at pi radians. And since r is 0, only looking at the x value at 3 pi over 2 radians. Ta-da! Now the y over x, I am going to have to build fractions for those. So here, y over x, 0 over 1 is 0. I can't remember if we said it yesterday in the video or not, but you know that means that tangent is sine over cosine, right? Did we say that yesterday? Yeah. Okay. So instead of saying y over x, I could just say sine over cosine. They're right there. Tangent's undefined on the y-axis because x is 0. Sine over cosine, or y over x, either way you're going to get 0. And once again, when I'm here on the y-axis, sine over cosine gives me -1 over 0, but that's just going to be undefined because I'm on the y-axis. Armed with all of this knowledge, we now have the ability to fill out the unit circle. But I'm not going to, because that's stupid. But let's talk about where things are positive. And realize if it's not positive there, it's negative there, okay? So, remember, in quadrant 1, what's positive? X, Y, or both? Both. Okay, so what we have here is positive X and positive Y's. What about over here? Positive Y but negative X. And then right here, negative Y's. Great. So in this quadrant, that has X positive, Y positive, oh, and by the way, radius is always positive. According to my X, Y, R's, what's positive? Sine, cosine, or tangent? All. All three, sine, cosine, and tangent, are positive there. So in quadrant 1, sine and its reciprocal cosecant, cosine, its reciprocal secant, and tangent, its reciprocal cotangent, are all positive. By the way, knowing it's a reciprocal, this is y over r, this is r over y. This is x over r, this is r over x. This is y over x, this is x over y. So as long as you have your x, y, r's memorized for sine, cosine, and tangent, you'll know these. Mr. M, I'm going to get confused. I feel like cosine should go with cosecant. And I go, you're not alone. The entire universe thinks that. It should go that way, but it doesn't. Okay? It's because the term secant was already something being used in geometry before trigonometry was discovered. And then they found out that their secant lines that they were drawing corresponded to the lengths of the reciprocal of their cosines. So they're just like, oh, well, that term's already used, so that's secant. That's how that worked out, okay? So what I tell my students is, your trig functions will come in SC pairs. Sine, cosecant. cosine, secant. SC pairs. One will start with S and one will start with C. Okay? SC pairs. Anywho, in quadrant 2, x is negative. That means cosine is negative, but what's still positive? Sine is still positive because sine uses only the y values in the unit circle. This is the unit circle, by the way, so we're saying that the radius is always 1. So in quadrant 2, both sine and its reciprocal are positive. However, now secant or cosine and its reciprocal secant are negative, tangent and its reciprocal cotangent are negative. In quadrant 3, the x's and the y's are both negative. So what's positive? Tangent. Because tangent is always going to compare the x's to the y's, you'll have negative y over negative x, and the negatives will cancel. So that means tangent and its reciprocal cotangent are both positive there, but cosine, which only uses x, and secant, its reciprocal, will be negative. Sine and its reciprocal cosecant, which only use y, will also be negative. And in quadrant 4, where x is positive, which trig function will be positive here? Cosine and its reciprocal, secant. So sine that uses y's will be negative here, so will cosecant because that's its reciprocal. We already said cosine, and therefore it's reciprocal, positive. Tangent, which uses x's and y's together, was only going to have one of them being negative, is going to end up being negative, and so will cotangent. And that, ladies and gentlemen, is how you nerd your way through not knowing the unit circle. Because who cares?